my created lesson plan, students were engaged in many science and engineering practices. Some of the practices they engaged in were planning and carrying out investigations, obtaining, evaluating, and communicating information, and constructing explanations. My lesson was focused on the DCI pertaining to forces in motion. This lesson informed students how different phases of matter correlate to different motions. To see this firsthand, students were presented with a hard-boiled egg, the solid, and a raw egg, the liquid. Then they were tasked to find which egg was the hard-boiled egg through investigation. In this picture, students were in the middle of carrying out their investigations. Collaboratively in pairs, students spun each of the eggs to see if there were any clear differences in their motions. The data collected during their investigation served as evidence that helped them form their explanations as to which egg they believed was the hard-boiled one. Their explanations consisted of their claim, which clearly states the egg they believed was the hard-boiled one, and was supported using reasoning and evidence. Also, throughout this experiment, students were obtaining, evaluating, and communicating information. Students continuously referred back to their observations and bar graphs while communicating their thoughts with one another. During our 1 ISM class period, Dr. Feltry proposed a scenario to us. Her scenario read, "I used to see a ton of rabbits in my backyard, but recently I haven't seen any rabbits." This scenario helped us as students engage in many science and engineering practices. The practices we engaged with were asking questions, developing and using models, analyzing and interpreting data, using mathematical and computational thinking, and engaging in argument from evidence. This photo shows our student-generated questions. Having us generate questions allowed us to spark our own interests and curiosities. Also, asking questions about data automatically pulls in other practices. As you saw in the previous slides, this lesson hits on many other practices. After we formed our student-generated questions, we were asked to collaboratively work in groups and draw a model depicting a food chain that we believe rabbits are a part of. Within this food chain, we showed matter and energy transfers and how they differed. This model showed relationships within natural systems and also later served as evidence as we engaged in argument as to what we believe happened to the rabbits in our professor's backyard. After our models were drawn and discussed, we were given this graph. This graph was titled Invaders and Ecosystems. Within this line graph, there were 4 different lines correlating to either the rabbits, grass, invaders, or foxes. This graph uses mathematical representation to describe relationships. It was our job as students to dissect what the graph was telling us. But in order to dissect the graph, we first needed to use our prior math knowledge in order to make predictions from the graph. The information in this graph provided us with the evidence that later helped us construct our argument as to where we thought the rabbits went and what happened to them. Also, providing this graph forced us to analyze and interpret this data. Appendix F reads, students are expected to improve their abilities to interpret data by identifying significant features and patterns, using mathematics to represent relationships between variables, and taking into account sources of error. In this experiment, we did just that. We analyzed the given graph and discussed the patterns and relationships between the 4 variables. After we analyzed and made our interpretations of the graph, we were able to engage in argument. In science, it is essential to engage in argument based off of evidence. Within this experiment, our evidence consisted of the graph and our drawn and created models. After we individually constructed our argument, we were partnered up and asked to read our explanations aloud to one another. After both partners read their explanations, we respectfully critiqued one another's. This was helpful because we were able to see other viewpoints and share what each of us thought. The egg in the bottle experiment can help students engage in the practices such as defining problems and designing solutions. This experiment would happen after students have experienced the phenomena behind the egg falling into the bottle. This could be used as a follow-up lesson. After students understand that the egg fell in due to unbalanced forces, they can be tasked with getting the egg out. Students would define the egg being stuck in the bottle as the problem, and they will have to use what they know to design possible solutions to get the egg out. Students can work together to generate and compare multiple solutions to get the egg out of the bottle.